Hello, so today I'll start by giving you some background about the two places we're focusing on, which is Sandakan in Malaysia and China. Firstly, Sandakan, Malaysia. Sandakan is a coastal town in Sabah, Malaysia. People here depend a lot on groundwater for farming and daily needs, especially in rural areas. The problem is that Sandakan relies on regular rainfall to refill its groundwater. But with climate change, rainfall is becoming less predictable. On top of that, rising sea levels are causing seawater to mix with fresh water For China, in the other hand, is a very huge country with very different climates. In the north, it's pretty dry, but so people use a lot of groundwater for farming. But in the south, there are more rain, but the water isn't always where it's needed the most. China also has problems with overusing groundwater in the north. This has caused things like sinking land and drying up underground water sources. On top of that, pollution from factories and farms is making the situation worse. So both places really rely on groundwater. The challenge they face are very different. Sandakan struggle with rainfall and sea level rise, while China deals with overuse and pollution.
Okay, so next is challenges. For Sandakan, tropical religion, first is sea level rise and saline intrusion. Sandakan, as we know, in area of Borneo, is vulnerable to rising sea level, which can lead to intrusion of salt water into coastal aquifers. This compromise the quality of groundwater, reducing its usability for drinking and agriculture. Next is increased rainfall variability. Climate change affect monsoon pattern, causing unpredictable rainfall. Next is deforestation and land use change. Sandakan dependence on palm oil plantation, and deforestation increases soil erosion, reducing groundwater recharge capacity. So loss of forest cover impacts water retention and aquifer replenishment. So next is limited groundwater infrastructure. Sandakan relies more on surface water resources, with groundwater often serving as a backup during dry period. And last is biodiversity dependency. Groundwater depletion affect mangroves and wetland ecosystem, which are crucial for biodiversity and coastal protection in the region. Okay, next for China, vast and diverse geographies. The challenge and impact for this, China, first is overexploitation of groundwater. Northern China, for example, the North China Plain, heavily relies on groundwater for agriculture and industry, leading to over-extraction. Next is the desertification. Regions like Inner Mongolia face desertification due to prolonged drought and reduced groundwater recharge. Next, seasonal water scarcity. Melting glacier in western China temporarily increase surface water availability but threaten long-term groundwater recharge once glaciers disappear. Next is urbanization and industrialization. Rapid urbanization and industrial growth increase water demand, putting pressure on aquifer. And last, flooding and infrastructure damage. In southern China, heavy rainfall and flooding can damage groundwater infrastructure and reduce recharge efficiency due to surface runoff.
Okay, next is the impact assessment of climate change on groundwater dependency. First is it will reduce groundwater recharge because altered rainfall patterns reduce natural aquifer replenishment, leading to over-extraction of rainwater. Next is increased agricultural demand because drought and rising temperature force farmers to rely more on groundwater for irrigation, risking aquifer depletion. Third one is saltwater intrusion. The rising sea levels cause salinization of coastal aquifers, reducing freshwater availability. Next is higher evaporation rates. Hotter climates increase water loss, driving greater dependence on groundwater. And the next one is groundwater quality decline. Extreme weather and overuse can contaminate aquifers with pollutants or natural toxins. And the last one is urban pressure. The climate, migration, and urban growth increase groundwater use in city, causing stress on aquifers. So here is the solutions for all the impact assessment. So first is we must promote water efficient practice. For example, drip irrigation. Second is we must recharge aquifers using rainwater harvesting. Third one is we must monitor groundwater use and quality. Build resilience with diversified water source. And lastly, groundwater sustainability is critical for adapting to climate change.
Hello, my name is Muhammad Iqbal bin Azri, and I'm going to present to you about innovation and strategies. So we got three of them, both for Sandakan and China. For Sandakan, we have rainfall gathering. It is to lessen dependency on groundwater for household and agricultural purposes. Rainfall gathering system are being promoted. And the second one is natural solution. It is to include conserving watersheds and restoring mangroves to enhance groundwater recharge and reduce saltwater intrusion. The third one is to localize community-based water management that balances recharge and extraction while preserving ecosystem service is known as integrated water management. For China, we have water-saving technologies, which is to adoption of cutting-edge irrigation methods such as sprinklers and drip irrigation to lower water consumption in agriculture. Second is to manage aquifer recharge, MAR, reducing over-extraction by using artificial recharge techniques such as introducing surface water into aquifers during rainy seasons. Last one is to desalination and recycling, to augment freshwater supplies and lessen strain on aquifers. There are large-scale desalination plants and water recycling programs.
Okay, so I'm Bilke Jyoti with number matrix BS 22001172. For this part, I will talk about recommendation and actionable solutions for some of the challenges. So, one of the solutions for the reduced groundwater recharge challenges is implement managed aquifer recharge. This is where develop and employ techniques for artificially recharging aquifers such as infiltration basins, recharge wells, and rain gardens, which can help increase groundwater levels. Next, for the increased agricultural demand. One of the solutions is adopt efficient irrigation techniques. This is where promote the use of water-saving irrigation methods such as drip and sprinkler system to minimize groundwater extraction while promoting optimal water use in farming. Next, for the problem, high evaporation rates. One of the solutions is optimize irrigation timing. This is where the farmers will be trained to irrigate during cooler parts of the day to reduce evaporation losses, which helps maximize water retention in soil. Next, for the problem, urban pressure. One of the solutions is develop water use program. This is where encouragement the use of treated wastewater for non-potable purposes such as irrigation and industrial processes to relieve pressure on groundwater supplies. Next, for the challenges of groundwater quality decline, one of the actionable solutions is monitor and regulate agricultural inputs. This is where implement regulation on the use of fertilizers and pesticides to minimize runoff contaminants that can seep into aquifers, promote organic farming practice that reduce the chemical uses. Other than that, the solution for increased agricultural demand is implement soil moisture management. This is where the farmer will also train to alter the soil moisture monitoring technologies that allow them to irrigate crops